In this video, we'll be going through an entire example of an independent t-test from start to finish, going step by step through that hypothesis testing procedure in this independent t-test situation. Let's get started. In this example, we see a group of researchers who want to see if an intervention will help individuals stop smoking, and they study two groups of smokers. One of these groups is given the intervention. And at the end of the study, they compare how much each group smoked. And so we see that we have the scores here for no intervention, and we have the scores here for those who had the intervention. Something that's notable here is that we can see that we can have an uneven number of people in our groups for this test. And this is something that'll really be specific. This is, I think, the only test that we're doing this with, but we can have an uneven number of people, and that's just fine. And we'll see that we actually deal with that within the test itself. And so our first step is going to be to restate the question as research and null hypothesis, just as always. And so in our case, we're going to say that people who receive the smoking intervention will have lower rates of smoking than people who did not receive the smoking intervention. And for our null hypothesis, we'll say that people who received the smoking intervention will not have lower rates of smoking than those who did not receive the smoking intervention. And so next up, we want to determine the characteristics of our comparison distribution. And in order to do that, our first step is always to ask, well, what is our comparison distribution? And here we're going to see that it's the distribution of differences between means. And again, this is because we always want our comparison distribution to match our sample. And here we'll see that our sample, at the end of the day, what we're going to be doing is we're going to be getting the difference between two means. And so here we need to use and compare that sample to a distribution of differences between means. So just some background information of exactly how we are going to get this information, what we have to do to get the information about our comparison distribution here. And so the first thing is for the shape. Our shape here is going to still be a t-distribution as in our dependent t-test, but here we're going to base this on the total degrees of freedom. And the total degrees of freedom is going to be the degrees of freedom from our first group plus the degrees of freedom from our second group. And so we're going to have to find the degrees of freedom for each group, df1 and df2, and then add that together to get df total. And we'll remember here that our degrees of freedom formula is n minus 1, and here the n is going to be the number of participants in just one group. We also have to find our mean. So we're going to calculate the mean for each sample, and we're going to assume the mean of the distribution of differences between means is 0. And this should sound kind of familiar. This is similar to what we did in the dependent t-test. And again, this is really just because the main idea here is that that comparison distribution assumes that our null hypothesis is correct, which means that there is no effect of, in this case, the smoking therapy. And that means that there's no difference. Once we get the difference, that difference should be 0. And so we're going to assume that this distribution, our comparison distribution mean is 0. And lastly, our variance and standard deviation. We can see there's a whole bunch of steps here. So we are going to calculate the estimated population variance of each sample, find the pooled estimate of the population variance, which we'll see deals with those unequal numbers of participants we have. We'll find the variance of each distribution of means, find the variance of the distribution of differences between means, and lastly, the standard deviation of the distribution of differences between means. And while these are several steps, and this is probably one of the more involved procedures, probably the most involved procedure that we'll go over in these videos, the important thing here is that, again, none of these individual steps are difficult really in and of themselves. Everything is pretty straightforward. The key here is going to be to just kind of take it step by step, one thing at a time, make sure that you're familiarizing yourself with the procedure and what happens at each step, not missing any steps, and knowing which formulas you can match to each step. And that's really going to be the key. And so we have our data here. So let's start putting this into practice. And so as we go to find our degrees of freedom here, you can see, let's take a look. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 people in one group, 10 people in the other. So for our df1, we're going to say that's 8 minus 1 is going to be 7. DF2, 10 minus 1 is going to be 9. Again, these are just the number of participants in each of those groups. And then we're going to add that together to get DF total, and 7 plus 9 is going to be 16. For our means, we're going to calculate the mean for each sample. And so this should be familiar to us at this point. We have our formula up here, sum of x's over n's, over n. And so we're going to just add up all of the scores for each group and then divide by the number of scores in that particular group. We see here that we get 50.75 and 54 for the no intervention and intervention groups respectively. And again, we assume that our comparison distribution mean is going to be 0. Moving on to our variance, we know that our first step is going to be to calculate the estimated population variance of each sample. We calculated estimated population variance in our dependent t-test procedure, and so we know how to do this already. We have 2 of them to do now, so that's a little bit more involved, unless you're given that information in the problem, which you sometimes might be. But we're just going to take it step by step. And so we're going to remember that that estimated population variance is going to entail getting those deviation scores, subtracting the mean from each score, squaring those deviation scores, adding those up to get the sum of squared deviations, or the sum of squares, and divide that by the number of scores minus 1. And so here I've started this process here. We have our formula over here. I've put up the means here for us to reference. And so we can see that for each group, I've subtracted the mean for that group from each score. So 50.75 over here and 54 over here. We've done all those subtractions. We're going to square all of those differences. Need a little more space here. So we're going to add up all of those differences, all of those squared differences. And lastly, we're going to divide by n minus 1, which over here will be 8 minus 1, and over here will be 10 minus 1. And so at the end here, for the no intervention group, we get that our estimated population variance is going to be 161.93, and our estimated population variance for the intervention group is going to be 61.11. And so now this part is going to be new. And so in this part, we're going to calculate our pooled estimate of the population variance. And so in particular, what this pooled estimate is going to be is we're going to basically be getting a weighted average. So let's get some of the logic behind this. So particularly, we're going to assume that our 2 populations that are represented by our 2 samples, the 2 populations that our samples come from have the same variance. That's our assumption here. But each sample is likely to have a different variance. And so we assume that our populations have the same variance, but our samples are going to have different variances. And what that means, how we get that to make sense, is that we interpret these 2 different variances of our samples as being 2 estimates of the same number. So we have 2 estimates essentially. The variances of each of our samples are each an estimate of the same population variance, because those 2 populations we assume have the same variance. And since we have these 2 estimates that are trying to estimate the same thing, we're going to average them to get one overall estimate. And that's what our pooled variance is going to be. And so specifically, each sample's estimated variance is going to be weighted based on the degrees of freedom, and then we're going to average them together. And so this is just going to be a weighted average, and particularly it's going to favor the larger sample. And basically this is because the larger the sample, the closer the number of people in that sample are to the number of people in the actual population. Larger samples are probably going to be a bit more accurate. They're based on more information. And so that's why we're going to weight this a little more heavily in the favor of the larger group. And so we have our formula here for the pooled estimate of the population variance. And so we'll see again, we'll kind of just keep going with these new symbols that we're getting. So here we have S squared pooled. And so estimated variance pooled is what we've got here. We're going to see that we're going to use the DF, the degrees of freedom formulas, our DF total, and also our estimated variances. And so the main idea here is that we're going to figure out what proportion of the total degrees of freedom each sample contributes, and then multiply that proportion by the estimated population variance from that sample. And we're going to just add up our results. So again, step by step, pretty straightforward. And so again, remember we calculated all these degrees of freedom already. So we have 7 for group 1, 9 for group 2, and 16 for our DF total. And so if I plug in these numbers, so 7 over 16, and again, we had our population variance already for group 1 and group 2. And again, plug in 9 over 16, plug in that estimated population variance. We're going to go ahead and convert those fractions into decimals here, do that division, multiply that out, and then add them together. And we're going to get that our pooled estimate of the population variance here is going to be 105.21. And so now we're going to take that and find the variance of each distribution of means. And so to do that, what we're basically doing here is we're going to take the population variance and divide that by the sample size. And we're going to do this twice. We're going to do this for each of our distribution of means. And so particularly, this is what we want to use both of these formulas, and we're just plugging in these numbers here. And so we have our pooled estimate of the population variance here. Put it up in the corner there so that we can reference that. And again, we're dividing by the number of people in our sample here. So dividing group 1 by 8, and we get 13.15. Taking the pooled estimate of the population variance, dividing by the number of participants in group 2, and that's 10, and we get 10.52. And so then we're going to take these and find the variance of the distribution of differences between means. And we're almost at what we really want here when we're getting to step 5. And so to get that variance of the distribution of differences between means, we want to take our variance of the population's distribution of means, and we're going to add those two together now. So the things that we just calculated in the last step, we're just going to add. So 13.15 plus 10.52 equals 23.67. Lastly, to get the standard deviation, whenever we have a variance, we know we can get the standard deviation just by taking the square root. And so I'm going to take that number I calculated in the last step, get the square root, and I'm going to get 4.87. And this is what I wanted. Now I have all of the information I need from my comparison distribution. And so we move on to step 3 here. And so for step 3, we want to go back and remember whether we had a directional or a non-directional hypothesis. We know we're going to be using the t-table, and so we have to determine which kind of test that we're going to have here. And so in our case, we're looking to see if this reduces smoking, and so that's going to be a one-tailed test. And our DF total here is going to be 16, and we're going to use that 0.05 level of significance. So I'm going to take our 16, move over here to the one-tailed test 0.05. We're going to see we have 1.746 or 1.75. And again, we're looking for a reduction in the smoking level. So that's going to be negative 1.75. And now we're going to determine our sample score on our comparison distribution. So we have our formula for the t-test for independent means. And we'll see that just like normal, these are all things that we've calculated at this point. So we have our mean from group 1, our mean from group 2, and that S difference. that standard deviation that we calculated. So I'm just bringing up those numbers again so we don't have to flip back here. And I plug in those numbers, mean 1 minus mean 2 over 4.87. I do that subtraction, do that division, and I get negative 0.67. And so now we have to decide whether we should reject the null hypothesis. And this step in particular is really just about always the same. And so we're going to do this just the same way that we've done for the z-test, for the dependent t-test, just the same now for the independent t-test. And so how do we decide? I always do like to make sure to visualize this. And so I recommend writing this down, drawing this out, whether you're drawing the distribution or just a number line like this, either is fine. And I'm going to remember that my cutoff score was negative 1.75, and my sample t-score was negative 0.67. And so we remember that if our sample t-score is more extreme than our cutoff score, if it's further into the tails, then we're going to reject our null hypothesis. In this case, our sample t-score is not more extreme than our cutoff score, and so we're going to have to fail to reject our null hypothesis here. And that's the independent t-test, start to finish. Again, this is a bit of a more lengthy procedure, but step by step, take it slow, get some practice with this, and it'll start feeling more natural.